Linear Programming Kcse 2020 Maths Paper 2 question number 21. The question reads, a road contractor has to transport 240 tons of hardcore. He will use two types of lorries, type A and type B. He has three type A lorries and two type B lorries. The capacity of each type A lorry is 8 tons, while that of B is 15 tons. All type A lorries must each make the same number of trips. Similarly, all type B lorries must each make the same number of trips. The number of trips made by each type B lorry should be less than twice those made by each type A lorry. And then each type A lorry must not make more than 6 trips. So that is the question. Part A of the question is, take X to be the number of trips made by each type A lorry and Y to represent the number of trips made by each type B lorry. Form all the inequalities in X and Y to represent the above information, 3 marks. And then down there we have the grid provided, draw all the inequalities and shade the unwanted region. Take 1 centimeter to represent 1 unit on each axis. That is 4 marks. And then there is a second question here which I need to make it clear. This is a part C of the question, and this one is the cost of operating each type A lorry is 5,000 Kenyan shillings per trip, while that of operating each type B lorry is 12,500 per trip. Determine the number of trips each type of lorry should make in order to minimize the cost of transporting the hardcore. Hence, calculate the minimum cost, 3 marks. So that is a question on linear programming. I want us to go to the first part of the question and read and form the inequality. So the statement is there. Part A, take X to be the number of trips made by each type A lorry, and this is something that we need to, so X to be number of made by each type A lorry, and Y to represent the number of trips made by each type B lorry. Form all the inequalities in X and Y. Now let's go to the first statement there, the first sentence. The road contractor has to transport 240 tons of hardcore. Then he has two types of lorries, type A and type B. He has 3 type A lorries and 2 type B lorries. Then the capacity of each type A lorry is 8 tons, while that of B is 15 tons. That up to that point we'll be able to form the first inequality. So let me use another space here. So he has according to this one, there are 2 types of lorries. So type A lorry, and this one is making X trips. And for type A lorry, we are given that he has 3 type A lorries and 2 type B lorries. So let us that. So for this one, he has 3 lorries, and then each lorry, type A lorry, carries 8 tons. Then for B, this one will cover Y trips. And then how many lorries are there for type B? There are 2 type B lorries. There are 2 lorries in that category. So there are 2 lorries, and each one of them is supposed to carry 15 tons. 15 tons. So 15 tons. All of these A and B, type A and type B lorries, have to transport a total of 240 tons. So let us begin by calculating the number of tons transported by type A lorry. That will be given by there are 3 lorries for type A. Then each one of them goes for X number of trips, and for each trip 8 tons. So that this one represents the tons transported by type A lorry. Then we add the tons transported by type B lorry. Type B lorries, there are 2 lorries. Each one of them makes Y number of trips. Each trip is 15 tons. So now this sum represents the total number of tons that are to be transported by the 2 of them. And the statement says that he has to transport 240 tons of hardcore. He has to transport 240. So that one means the number of tons to be transported should be greater than or equal to 240, but not less than. He has to transport 240 tons. So therefore, the number of tons should be greater than or equal to 240, but not less than. So the inequality sign that should be here is therefore greater than and or equal to 240. The 2 lorries should do that. So we multiply these, and this is what you're going to get. So this will give 24x plus 30y should be greater than or equal to 240. Now, upon getting that, we can simplify this equation, and simplifying this, we shall divide. If we divide by 6, if we divide all through by 6, this is what you're going to get. If we divide by 6, the first inequality will be 4x plus 5y greater than or equal to 40. So that is the first inequality. That is the first inequality that you're supposed to get. Now let's go to the second inequality and see where we are going to get that. Now from that statement, we move from this statement where we have all type A lorries must each make the same number of trips. Similarly, all the type B lorries must each make the same number of trips. We don't have any inequality that we can form at that point. So we go to the next sentence. The number of trips made by each type B lorry should be less. I think here we should have an inequality that the number of trips made by each type B lorry should be less than twice those made by each type A lorry. So how do we form that? That one will be Y. That is the one that represents the number of trips made by type B lorry, and that one should be less than twice the ones made by type A lorry. So should be less than twice the number of trips made by type A lorry. Since type B lorry makes Y trips, then type A lorry makes X trips. So this is the second inequality. And then from there we go to the other inequality. We check whether we can form another inequality. The last statement there will give us the other inequality. The last sentence: each type A lorry must not make more than 6 trips. Must not make more than 6 trips. So that one means must not make more than 6 trips. Means that type A lorry should make less than or equal to 6. That is what we mean, that it must not make more than 6 trips. So that means type A lorry must make less than or equal to 6 trips, and for type A lorry makes X trips, So this number of trips must not be, let me read the statement again, must not make more than 6 trips. So it should be less than or equal to 6. So that is where we have the third inequality. So these are the 3 inequalities that we have formed from that statement, or that's the whole statement that we have there. I don't think we have any other that we can make. And then now from there, I think I need to add a page here. Yeah, need to add a page. Now from there, go to the next question. Part B, on the grid provided, draw all the inequalities and shade the unwanted region. Take 1 centimeter to represent 1 unit on each of the axis. Now the 3 inequalities that we have formed, we need now to graph them. We plot them on the graph. Now let us take the first one, 4x plus 5y. The first one is 4x plus 5y. This one is greater than or equal to 40. That is the first one. Now this one, we need just to assume that this one is equals. We assume that sign equals. The way we can take this 4x plus 5y is equals to 40. We just take that one as a normal equation of a straight line. And how do we draw a straight line? We need how many points? We need at least 2 points. At least 2 points to draw the line. But you can use the third one for confirmation. So using this equation, we can fill that table. So we can start by the first one. And the first one is when we calculate here, when x is 0, you'll get y will be 8. Then if you use when x is 10, substitute in that equation, you get 0. Then when it is 5, you'll get this one is 4. So this is what you're going to use to plot, and that is what you're going to use to plot that. Now we go to the second one, which is y is less than 2x. So y is less than 2x. For this one again, we can make a table and use at least 3 points, and we can assume that this one is just y is equals to 2x, and we draw a straight line. So this one will be, if we take let's say x is 0, y will be 0. Then when is 1, this one will be, when x is 1, this will be 2. Then when it is 4, this will be 8. So we are going to use these points to plot. Then the last line is where we have x is less than or equal to 6. So x is less than or equal to 6. Now this one we are going to simply draw line x is equals to 6. And then one thing to note, for the first line, this line will be continuous. This line will be continuous line, as you're going to see. This line will be broken. You can see this one will be broken line. This one is less than. This one has greater than or equal to. So this line will be continuous. It is very important to note that. So this will be the first one. This one will be a continuous line. This one will be continuous line. You can see because the inequality sign has equal sign, and this one, the inequality sign doesn't have the equal sign, just less than 2x. This one will be a broken line. So let's go now directly to how we are supposed to plot the point and draw the line and show the inequalities and shade the unwanted sides. So let's start by drawing the lines. So the first line that you're going to draw is this line, which is here. 4x plus 5y is greater than or equal to 40. So the points you're going to use is 0, 8, 0, 8, 0, 8. We plot that. 0, 8 will be here. 0, 0 is here. Then 8, 8 is there. Then 10, 0, 10, 0 is here. 10, 0, and then 5, 4. 10, 0, and 5, 4. So 10, 0, we have 10, 0 here, and 5, 4. So this is 5, 4. 4 is there. So those are the points. So the first point is 0, 8 is there. Then 5, 5, 4 is here. The point is there, and then 10, 0 is there. That line should be continuous. It should be continuous. The line should be continuous. That is the line. So let me zoom it a little bit. So there is the line. So that is how it's supposed to be. So after drawing that line, we need to go to the other point, which is knowing the side that you're going to shade. Remember, we shade the unwanted side. So on deciding on the part that you're going to shade, we just need to use this paper here. We just need to pick a point that is either on one side of this, either this side of this line or this side of this line. So let me pick a point that is on this side, which is the origin 0, 0. I pick a point like 0, 0, and then I want to test in this equation 4x plus 5y. 4x plus 5y is greater than or equal to 40. So if it satisfies, that is the required region, and I will not shade that. If it doesn't satisfy, then I know that is the unwanted side. So when x is 0, y is 0, substitute here. This will be 0 plus 0. When you substitute this x here, 0, then y, 0. So you get 0 plus 0, which is greater than or equal to 40. So this one, does it satisfy? Is 0 greater than or equal to 40? No. So that one basically tells us what? That the unwanted side is this side that is here. So the side that is below, that is the side I've picked the point 0, 0, and it has not satisfied. So that is the unwanted side. Now let's go to plotting the other line. So the other line is here. Y is less than 2x. So I'll plot 0, 0, 0, 0, 1, 2, and 4, 8. 0, 0, 1, 2, and 4, 8. 0, 0 is here, the origin. 1, 2 is here, and 4, 8. 4, 8. So those are the points. So 0 0 is here, then 1 2 is there, then 4 8 is here. So that line, because as you can see, this is less than, so this will be indicated by a broken line. We are going to use a broken line since it is less than, just less than. Points that lie on that line will not satisfy the inequality. So for this one, we are going to use the broken line. So let's draw the line. So that is the line y. Go to indicate the equation of that line. So let me read clearly. So y is less than 2x. Y is less than 2x, and then this other was 4x. This was 4x plus 5y is greater than or equal to 40. That is this line that we've drawn. Now we are remaining with only one line now. We have one line to go, and this is the line. The line that is remaining is this: x is less than or equal to 6. So that one you're going to draw a continuous. This one will be a continuous line. Why? Because you can see this is a sign. The inequality sign has an equal sign. So meaning that points that lie on that line will satisfy the inequality. So we draw this line. X is equals to 6. X is equals to 6. And this is the line. So I need to extend this. Extend that line. Then x is equals to 6 will be here. X is equals to 6. The straight line that passes through here, and this line will be continuous. So that is the line. This is y is equals to, this is x, sorry, this is x. X is less than or equal to 6. Now there's something that we have to do for the two lines that we've drawn. Let us start with these. X is less than or equal to 6. So which side are we supposed to shade? Is it the right hand side of that line or the left hand side? Now looking at these, the required region is less than. The required region is less than. So the unwanted side is the side that is to the right of that line. The side to the right of that line is greater than. It is greater than. And we require the equation, the inequality is x is less than or equal to 6. So the required side is the left hand side of this line. So this is the unwanted side, and then this one is the required side. Now there's this line that is here that we have not shaded. Y is less than 2x. There's this line, the broken one. So how do we determine the part to shade? Now this is what you do. When you look at this line, we just need to pick either a point that is on this side of this line or on this side. So either a point on this side or on this side of this line, this broken line. So let me pick a point like 0 1, 0 1, or maybe I can pick a 0 5, 0 5, as long as the point that I'm picking is on this side, either this side or this side. So let me pick this side. You can pick any side. So I will pick this side where you have 0, 5. So now you have the equation here, y. So you have y is less than 2x. So if I pick a point like the one I've said 0, 5, so x is 0, y is 5. So 5 less than 2 times 0. We substitute 2 times 0, x is 0, so this will be 0. So does that side satisfy? Is 5 less than 0? No. So that side I have picked that point on this side, 0, 5 on that side of that line. So that side doesn't satisfy the inequality, so that side is the unwanted side, and we shade the unwanted side. So we shade the unwanted side. So as you can see now, we have shaded everything, and now we have the required region. The required region is the region that is here, that is shaded. So that is how you're supposed to graph the inequalities. So as you can see, you have the area that is unshaded, that is the required region, and this is the required region bounded by those lines. Now, having done that, the next question is calculate the number of trips for both x and y. So these x-axis, these are trips by type A lorry. That is trips by type A lorry, which we give as x. Then on the y-axis, these are trips by B, and this is what we gave as y. Now, to get the number of trips that should give minimum cost, the one that would minimize the cost, how do we do that? Using these inequalities that we have graphed here. The number of trips made by type A lorry and type B lorry that should minimize. That is the main thing. We can maximize or we can minimize. Now, to do that, the best method that maybe is not the best, but one of the best methods to do this is whereby you use the inspection method. You can use the inspection method to know that. And what do you use? You look at the corners. These are the corners of this region that is satisfying. So there is that corner, and then there is this point also here, and also there is this corner. So what you do to know the values of x and y that would maximize or minimize the profit or the cost, you should try to feed in the objective function these points, the values of this point, because each one of these points will give the x and the y coordinate. So part C of the question, the cost of operating each type A lorry is 5,000 per trip, while that of operating each type B lorry is 12,500 per trip. Determine the number of trips each type of lorry should make in order to minimize the cost of transporting. So the question here is minimize to get the minimum profit. So what you need to do, we need to test like this corner. This is the first corner that is bounded by this line. This is 6 and something there. I can see the decimal. Then there is this one. Now for these, the one that I'm pointing, that is 3 this point will not be applicable in this case. Why? Because the point lies on that line that is broken, and points on this line would not satisfy the inequality. So this corner, we're not going to use this corner. We are not going to use this corner as well, because it lies on that line that is broken, and points on that broken line will not satisfy the inequality. So we therefore remain with only this point that is here. Now when you look at this point that is here, there's something that you notice. We want to get the number of trips, and when you're getting the number of trips, that is going to give the minimum cost of transporting. This point is 6, and I can see this one is 6 and 3.2. So 6 and 3.2, you're talking about the number of trips. So we are not going to consider this point that is here, and the reason is because we cannot have incomplete. You can see we have 3.2 trips. It doesn't look, we need a whole number to give the number of trips. So for that matter, we are not going to consider this point that is here. So if that is the case, we try to test now. We can do some inspection and test, let's say we can test these 0.64. We can test 0.64, and we can also test that is 64, which is here, and then we can test also 65. We can test 65, and as well we can also test on this line that is here. We don't need to test all the points. So the point that are lying on whole numbers, that will give whole numbers and not decimals. So we have 5 4 5 4 5 4 is there. When I look at the other points on that line, I don't see any other point that is going to give whole numbers for both x trips and y trips. And we have excluded this corner here and this corner on the basis of they are not lying, they are lying on a line that is not satisfying the inequality. So the points on that line will not satisfy the inequality. That is why we don't consider those points. So on this line that we have here, we will only have 5 4. We don't have any other point that will give a whole number. We don't have. So then on this line, I have picked a point to test, to inspect 6 4 and 6 5. So the first thing when you are testing this point, the one that will give you maximum and minimum, look at the corners. You need to look at these corners. You can test points on these corners. These are the corners. And then if you find a case like this where when you look at this corner, these corners here, they are lying on a line that is broken, you have to go ahead and test other points. There's another method that I'm going to prepare a tutorial for that, for sliding method. That is why you draw a parallel line and slide. That is also very useful. So let us test these points that are here. Let us test these points 6 4, 6 5, and 5 4, and you're going to do that in the objective function. So there's something that you're going to get here that you're going to use to minimize, and that is the objective function. Objective function. The objective function for type A is 5,000 per trip, and it makes x trips. And then for type B, it is 12,500 per trip, and the trip for B is y. This is what is going to give the cost. So this is what we call the objective function. The number of trips, and for A is x, cost per trip is 5,000, and then the number of trips for B is Y, the cost per trip is 12,000. So the cost is going to be given by this sum. Now we need to get the number. What we are required to get is the number of trips for X and Y, these values that will minimize the cost. And we have checked the points that you're going to use from the graph. From the graph we have using inspection method, where you inspect the points. We have noticed that we are going to test a number of points here, and the first point that you're going to test is 6, 4, 6, 5, and 5, 4. These four, the one that will give the least cost is the one that you're going to pick for that matter. And let us do this. So we are going to start with the first one. So 5,000 x plus, now the first one is we rub this. Now we start with 6, 4 plus 12,500. You're starting with the 6, 4, and this will give, we will get that cost. Then the second one, we shall work out that later. The second one is 5,000 6, 5 and then we shall test also the other one. So let's now calculate these. Let's calculate these and see the one that will give us the least. First one is this will give 80,000, and then the second one that is 6, 6. This is 6, 5, not 6, 6, 6, 5. 92,500, and then the last one is 4. This will give 75. So these are the costs. Now we need to check the one that has given us the least cost. That is the one that is going to give us the minimum cost, and automatically, as you can see, 5, 4, this is the one that has given us the minimum, so the least cost. So therefore the number of trips that will give for X, so for X 5, these are 5, and then for Y this is 4. So these are the trips, and this is by lorry B, and this one is by lorry A. So lorry A will make 5 trips, and B will make 4 trips. That is what will give the minimum the minimum cost. Now we need now to go back and read the question again. Determine the number of trips made by each type of lorry. We've got that. And the next thing is we have to calculate the minimum cost. We have now to calculate the minimum cost. So that is what we need to calculate now. We need to remember the number of lorries for each type. Remember, for lorry A, for type A, there were 3 lorries, and then for B, there were 2 lorries. So to get the total cost to be given by, for type A, there will be 3 lorries, each one of them making 5 trips, and the cost of each trip for that is 5,000. Then for lorry B, there are 2 lorries, then each one of them makes 4 trips, and one trip is 12,500. So we need now to work out these and get the cost, the minimum cost. So we have 5,000 multiplied by, this will be 15, and then 12,000 multiplied by, this will be, so this will give 175,000 as the cost. And that is simply how you're supposed to solve that question.